Good morning, everyone. Uh, the first program in the syllabus, interface part B program, that is displaying Hello World using UART. So for that, actually, we are loading the program into my ARM processor, and the ARM processor will send the Hello World message to computer. Okay. Uh, so using UART. So this is the program. In this program, we have initialize clock, initialize UART, U0 write, send string, okay, and what is the string? These are the initial values. Next, we'll come to the program directly. Instead of showing here, I will show in the field software. Already I have typed the program to interface. Okay. First is initialize clock. So initialize clock means actually we are converting the clock. What we are connected is 12 megahertz. So this will convert that clock into 60 megahertz internally. Okay. So internally it is converting that into 60 megahertz. So we'll see the program inside that initializing clock. So initializing clock, we have a set of instruction. This is a trial and error method code, because to convert that 12 megahertz to 60 megahertz. Okay. Uh, so there is enable PLL, next multiplier and divider, PLO feed sequence, PLL feed sequence once again. So it is going to change the uh, frequency. Okay, 60 megahertz. How it is changing, I'll show in the simulation. Okay. Next, we have a send string function. It is going to copy the string and directly write into u0 write. So we'll see what is that u0 write. U0 write is, it is a one register for transferring data. Okay, so the data what we want to send, that should be copied into u0 slr. Okay, u0 slr register, and if that is not uh, 20 hexa number 20, until that it is going to send it. Okay, and one more condition is, like, it is keep on checking whether that data is transmitted fully. It is 8-bit data, so serial communication. So in the serial communication, it will wait for completing the transmission. Okay. And one more function is initializing UART. So we want to initialize the UART for okay, first is there is two UART in the ARM processor. Okay, one is in P0. So P0 0.0 and P0.1. Okay, these two pins, that is RX TXD and RXT pin of our processor, we want to use for that function. I mean, you can use that pin as a general purpose processor, but I want to use it as a special purpose. For that, first I should select this P select 0 0 0x5. Okay, what is that? We'll see here in the PowerPoint. sorry, microcontroller. Okay, see here P0.0, I want to use it as a TXT. So if I want to use it as a TXT, the value should be 0 1. So this value should be 0 1. The next P0.1, I want to use it as a RXT, so that value also should be 0 1. So 0 1 0 1 means it is 5. So pin select 0, I am going to load. For pin select 0, I am going to load 5. Okay, that is what I am doing here. Next, U0 LCR, U0 DLL, this is the values to select 1 bit, I mean 8 bit data, no parity, and 1 stop bit. So, and to set the baud rate, we are using these values. Okay, so this is also the trial and error method. Okay, because we are by using like this for 60 megahertz, approximately we'll get 9600. How much we are getting exactly, I'll show in the simulation. Okay, so this is about all the functions. So in the main program, what we are doing is first initializing clock, means we are converting into 60 megahertz. Next, initializing UART. So we are making that 8-bit data transmit with one stop bit, one start bit, and no parity bit. Okay, and sending string, we are calling that value and sending until it is the THR register is active. It is keep on sending that uh, data. Okay, so okay, so this is about our program. Now I'll show the simulation here only. I'll load this file. Okay, under this group. Okay, it created the X file also, and there is 0 error. Okay, see the execution. Okay. Now I'll start pressing function F11. So initializing clock. Sorry, initialize clock. It is going inside now. Initialize clock. Okay. Next, I am loading here PLL configuration, phase lock loop. Okay, these values. This is to convert my external frequency 12 to the 60 megahertz. So, external frequency is 12 megahertz. The same clock frequency also is same. Now I want to convert this clock frequency is same as phase frequency. Okay, processing clock frequency. So first I should convert this external frequency 12 into 60 megahertz. For that, these steps are used. Okay, so I'll execute this. PLL con is 0 1. You can see there it is 0 1. Next ALLO 0 configuration, it is 24. Next A55, okay, this is the first feed. Next after some duration, again making a 03 A55, okay. Till now it is 12 clock. Now after executing this last instruction, you can see here this has become 60 megahertz. So these steps, there is a 7 instruction. This 7 instruction to convert this clock into 60 megahertz. Now next is make that clock 60 megahertz is equal to the uh, clock signal crystal clock. I mean clock frequency is same as a processing frequency. Okay. So for that I'll make VPB DVI, this register is 01. Now it is here P clock is equal to C clock. Okay, you can see here VPB DVI is equal to 01. This is about initializing clock. Next we want to go to initializing UART 0. So initializing UART 0, for that we should check this one. Okay. Pin select 0 is 05. Why we are doing that pin select 0 is 05? Yeah, I already told, but again I will show that. Okay, pin select 0 is 05 because 01 will make it as 0.0 in P 0.0 as TXT line, and P 0.1 RXT line if you want to use, then we have to make it as 01. So 0101 is like 0101 is 5. That's why it is pin select 0 is 05. Okay. Next, this is a standard code, standard values for setting the baud rate. Okay, setting the baud. And so the first U0 LCR, here it is. If I load 0 into this, okay, if I load 83 into this, then word length is 8 bits, stop bit is 1, start bit is 1, and no priority bit, okay, parity bit. So I'll execute this. Yes. Now by 83 means now the word length is 8 bit, stop bit is 1, and hot parity. Okay. So okay, this is the this is what I have changed. Next U0 DLL, it is to use change my the baud rate. Okay, how it is working you can check here. U0 DLL, that is 110 is equal to 60. Next it is 1. So what we are doing is multiplying by 15 and dividing by uh, multiply by 15 and divide by 1. Okay. So the final value what I need is the baud rate. Okay, where is the baud rate here? Yes, here the baud rate. This is the baud rate. So this baud rate I want to change into 9600. So these are the standard values should be loaded into that register. Okay. So after executing this, now you can see the baud rate is 9604. That's why I told it is approximate. Next, I'll come back to the main program. So initialization is done. Next, send string. So I'll copy the string into the UWrite, and it will start sending the value until you all the character is sent. Okay. So until all the character is sent, it is keep on sending the data. Okay. Now we'll see the same program after loading into the kit. So for that I should open this This is your microcontroller. The TX line and RX line, if we have to consider, we are connected that to computer, and in the computer we are getting some output. Okay, so that is what we want. So in computer we want, computer command window, we want the display like hello world. So from the microcontroller it should send display hello world. I have created the hex file. So try check this one. I created the hex file. Now just run that program. Now we'll run the program. When we are running the program, we got the virtual window just displaying hello world. Now, if we have any confusion like whether it is the same message it is displaying, we need to understand. I'll change the program. Okay, so in the program, I'll change the data, that is instead of hello world, typing here hello HA. Okay, now it should display hello HA. So first I'll build it. We're going to create a hex file and open Proteus execution. Of this execution, load the program. Run this program. So when it is running, it is displaying now hello HIT. Okay, this is what our program. We want to display hello HIT continuously. So it will keep on displaying this hello HIT. Thank you for watching. Now we'll try this code in our kit. For that, we need a flash magic, but before that, to select the COM port, we have to connect USB cable to the kit. So like this, the USB cable from your kit, it is connected to the uh, microcontroller kit. Okay, so once it is connected, uh, we can start uploading the file depending on where that USB mm, port is, COM port of USB port. So once we are uploading the file, now to see the message, actually the message it is sending from the microcontroller to the computer. So we are using this flash magic only to see the output, and in the tab of flash magic we have a terminal. So we should open that terminal depending on the where that USB cable is connected to which port it is connected. So when I am clicking on reset button of my kit, it will start sending the message. That message is hello world. So from the kit we are getting the message, the hello world, in our PC. So it's working properly. We can see that it is sending the message.